protect the iron from rusting, we can deposit a layer of zinc on it with the help of electrolysis, with the help of electricity, and that is called as galvanization. Or we can either make alloys of iron, like for example a stainless steel, or we can simply paint the surface of the iron to prevent it from rusting. Some of the natural chemical changes that happens in our daily life, even our body also participates in that, is like respiration. In the case of plants, they do photosynthesis. These were also the examples of chemical changes, because in the case of respiration, the glucose will be reacting with oxygen to give out a new substance, that is carbon dioxide and water, along with some release of energy as well. In fact, there are some organisms that can carry out this process of respiration in the absence of oxygen also. So they are like anaerobic bacteria. They can break down the food even with even in the absence of oxygen. Getting it?
Yes, sir.
Like we know that bacteria, they can survive in almost every condition, whether it be the hot springs, whether it be deep under the oceans, whether it be even in the mouth of the volcano, they are known to survive there as well. So at certain places, oxygen is not available, like deep inside the ocean. Oxygen is not available in the free state now, like it is dissolved in the water. So there they would be doing anaerobic respiration. Okay. Then in the case of photosynthesis, we did learn about that carbon dioxide and water, it will be combining in the presence of light. A reaction will take place between carbon dioxide and water, and as a result, glucose and oxygen will be given out. And why this is considered as a chemical change? Because a new substance with different chemical property is being formed here. Got it? Then we have some examples of man-made chemical changes, like burning of the fossil fuel, cleaning of a tile with the hydrochloric acid, or softening of the hard water using some chemicals like calcium hydroxide can be used to soften the hard water, or cooking of the food. That is also one such example. We were learning about the burning of the magnesium strip. So we did learn about this burning here. Like we simply take a piece of magnesium ribbon and hold it above a fire, so it will be violently reacting with oxygen, meaning that a bright light is given off, bright white light is given off, and then magnesium reacts with the oxygen to give out magnesium oxide, which is white in color. So we can correct it in this china dish. And the important thing, as we have discussed, that whenever any given metal reacts with oxygen, now, like metals or any given object that are hard, that are shiny, that do not break easily, they are called as metals now. So magnesium, iron, aluminum, zinc, gold, silver, all of these are metal. So whenever metal would be reacting with an oxygen, it will give you an metallic oxide. It gives a metallic oxide like magnesium oxide. Magnesium is the metal. Oxide here refers to oxygen, like MgO. Mg is in short for magnesium, O for oxygen. So that is magnesium oxide. Now, metallic oxides, they are basic in nature. They are basic in nature. Okay. So how do we confirm that? In order to confirm that this is basic in nature, what should I do? I should be adding something in it. I should make a solution of it now. So I'll be adding water into it. So when I add water into it, so here also my observation says that I am getting a chemical reaction here as well. A chemical reaction occurs here as well, because a new product, magnesium hydroxide, is formed. Got this result.
Yes.
Now when we dipped a red litmus paper in it, the color changed to blue, indicating that this is basic in nature. This was the confirmation that this magnesium hydroxide is basic in nature. So magnesium oxide, that is also basic in nature. Getting it?
Yes.
So we had learned about these things. Then we were learning about reaction between copper sulfate with iron also. Okay, in this I would like to ask some questions. What was the color of the copper sulfate?
Blue.
Blue. Very good. So when it reacts with iron, what does happen? Its color changes to
Green.
Why is it so?
Because
Because yes, because here iron sulfate is found, which is green in color. Getting it?
yes.
Here what happens? like copper sulfate, which is blue in color, it reacts with iron. Now, as a reaction, we have learned that iron would be reacting with copper sulfate to give out iron sulfate. Okay, now, and copper is also formed here. So that was the reaction. Copper sulfate reacts with iron to form iron sulfate, and the copper would be depositing on this iron blade here, for example. Okay, you saw this video as well here. Just look at it once again. You have making a solution of copper sulfate. Iron nail has been dipped here. Now notice the color change to greenish. And the copper deposited over the iron nail here, which is brown in color. So this is the reaction that occurred here. This is the reaction that occurred here. Getting it? So iron sulfate plus copper was formed. Iron sulfate is green in color, while copper sulfate was blue in color. That is one thing we have learned. Okay. Today we are going to continue with this reaction between the vinegar and baking soda. Okay. Vinegar, also called as silica. In Urdu, it is also called as silica, right? Okay. Razan, by the way, what is your mother tongue like? Do you speak Urdu or not?
What?
Do you speak Urdu or not? Like, you are familiar with Urdu words or not?
We talk Beri.
Bailey.
Beri.
Okay, okay. Okay. By the way, you are from India now, or from different
Yes.
country? Okay. Like in India, from which state?
Karnataka.
Karnataka. Okay, okay. Okay. So take the example of vinegar. Vinegar, it's used in your kitchen. It is added into several food items. It is also used as a food preservative. Okay, and it is also added in some food to prevent it from contamination, to prevent it from spoiling. So we can take some acetic acid. Here we have taken some acetic acid. Like vinegar basically contains an acid in it, called as acetic acid. So we have taken vinegar in this. We have taken a glass test tube. In this, vinegar has been taken, and we have taken a pinch of baking soda. Baking soda is also added in the food items now.
Sir,
So yes, Razan.
in class, today only we started this lesson.
In your school.
Yes.
Okay, okay. The same topic was going on or a different topic?
I don't know. I'm in India. My friends sent me the notes.
Oh, okay, okay. Okay, no issue. Okay, so talking about this reaction, so we have taken some vinegar in the glass test tube. Now we have added just a pinch of baking soda in this. So after few seconds, we will observe that bubbles will start to form inside this beaker. In this glass beaker, bubbles starts to form. What basically happens here? The vinegar here has reacted with the baking soda. Vinegar here reacts with the baking soda, and as a result of that, carbon dioxide gas is released here. So these bubbles that we observe here now, these bubbles are of carbon dioxide gas. These are
Carbon dioxide.
carbon dioxide gas. Okay. So this carbon dioxide gas now passes via this bent tube. Okay. So we take out this carbon dioxide via this bent tube, and this bent tube has been dipped into another test tube. It has been dipped into lime water in this test tube. Okay, now there is lime water. So the question is, what is lime water? Basically, it's calcium hydroxide. Lime water is what? It is calcium
dioxide.
hydroxide. So we have taken calcium hydroxide in another beaker here. And this test tube is not above the solution. It is dipped into the solution. So the carbon dioxide are going into this. Carbon dioxide gases are going into the lime water. That is calcium hydroxide. So these bubbles here are of carbon dioxide. Okay. So here, two reactions have taken place here. In the first place, what happened? Reaction between vinegar and baking soda gave out carbon dioxide gas. So a chemical change has taken place here. Getting it, Razan? And here also a chemical change has taken place here, where what is happening, that this carbon dioxide gas reacts with the calcium hydroxide, and two new products, namely calcium carbonate and water, will be formed. And water will be formed. So let me write down the important things here. Basically, what happened in the first one now, like in this, if I were to write down the reaction, let us call that this is a beaker A, this is beaker B. So in beaker A, what happened? In beaker A, what happened here? That vinegar reacted with the baking soda to give out a gas, to give out a gas that is carbon dioxide. In short, I'm writing this as CO2. Okay, it should be understandable. In short, I'm writing this as CO2. In beaker B, what is happening? This gas that is carbon dioxide is now reacting with the calcium hydroxide, also called as lime water. Okay, so it reacts with calcium hydroxide, and as a result of the reaction between the two new products are formed. One is calcium carbonate. One is calcium carbonate. Another product that is formed, that is water. So in both the cases, these are the examples of two chemical changes or not?
Yes.
Both of them are chemical changes. Okay. An important thing to be noted down here, that when carbon dioxide gas passes into this beaker that is containing lime water or calcium hydroxide in it, so when the reaction between carbon dioxide and calcium hydroxide takes place, this lime water turns milky in color. The lime water turns milky when carbon dioxide is passed through it. Why is it so? Like milky means that white in color now.
Yes.
Why it turns? Because the product that calcium carbonate is formed, it is white in color. This is white in color. That's why lime water turns milky, because of the formation of calcium carbonate. You got all this? Okay, just read the whole step. Okay, now to solidify the concept, just go through the paragraph. Read this. In fact, this can be carried out at home also. Yes, Rozan.
Yes.
Any confusion in this topic?
No, sir.
Okay. So just tell me why the lime water. What is the another name for lime water? Like lime water, what is it basically? It's calcium
Calcium
hydroxide. Calcium
hydroxide.
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 That is what lime water is. Good. Okay. Why the color of lime water turned milky when carbon dioxide was passed through it? Why its color changed to milky?
Because and carbon dioxide is passed due to
Hmm. Due to formation of a substance
formation of the substance.
that is calcium carbonate.
Calcium carbonate.
Okay, do let me know. Have you noted down the previous notes? Have you noted down these reactions previously or not?
Yes.
You have?
Yes.
Okay, now till the reaction of copper sulfate and iron, it was you have noted it down. Okay, so note down this one also. Just write down the reaction between vinegar and baking soda. First, give this topic. Then you will be writing down what I will be telling. Okay, give the topic. Give the topic reaction between vinegar and baking soda. also, whenever a reaction takes place and we don't know which gas is formed in that reaction, whenever a chemical reaction will be taking place and we don't know which gas is formed, whether it is carbon dioxide, whether it is nitrogen dioxide, whether it is oxygen, whether it is hydrogen, let's say we don't know about that. Okay, so how can we found out that it's if it is carbon dioxide or not? Let us say we want to see if it is carbon dioxide gas or not that is released in the reaction. So the best way to find out now, this is the standard test. Just dip that gas into this lime water. Just make the carbon dioxide gas go through this lime water. If lime water turns milky, so it's a confirmed test that the gas formed in this reaction or any other reaction is carbon dioxide gas. Getting my point or not? What I'm saying?
Yes.
Okay. Okay. You have given the topic.
Yes.
Okay, so you will be writing that when chemical reaction takes place, write down this. When chemical reaction takes place between
What?
between vinegar, when chemical reaction takes place between vinegar and baking soda, carbon dioxide gas is given off. Carbon dioxide gas is given off O double F. Okay, now O double F. Carbon dioxide gas is given off, and when carbon dioxide
Carbon
gas
dioxide
is given
given
off,
off.
and when this gas is passed through lime water, then lime water turns milky. Then lime water turns milky because of formation formation of calcium carbonate. Because of formation of calcium carbonate, along with that, because of formation of calcium carbonate, and along with that, water is also formed. And along with that, water is also formed.
Yes.
Done?
Yes.
Okay. Write down these two things. Note it down. Okay. Write carbon dioxide in full words, not in short form. Okay.
Yes.
Done?
Yes.
Very good. Now we are going to learn about crystallization. Okay, now. So talking about crystallization would be simply the formation of big and pure crystals of a substance from the saturated solution. Like it's a common observation, you have seen that in the summer season, like in the winter season, let's say you have purchased a bottled honey. You have purchased honey from the market in a glass bottle, let us say, in the summer season. When it will be the winter season now, you will observe that in the winter season, crystals of honey will be forming at the bottom. Have you observed that?
Yes.
Honey solidifies in the winter season. Mhm. It looks like little crystals. So crystallization is simply the formation of pure crystals of a given substance from its saturated solution. Also, this crystallization has been considered as a physical change here. Also, this method of crystallization, we can also do this. We can also perform this on order to in order to purify some substances. Let's say you have some impure substance, so you can purify it with the process of crystallization. Okay. Also, the process of crystallization is observed in the nature also. Like for example, the formation of different kind of gemstones. Gemstones are also formed via slow crystallization. Different kind of gemstones that we have, they are also formed by the method of crystallizations over the course of so many years. Getting it? So like so many different kind of precious rock stones that we have, they're also formed due to slow crystallization method. Getting it? Like for example, take the example of ruby, uh, take the example of topaz, take some other examples of some other precious stones. All of them are formed via the process of crystallization. So let us understand what basically happens in this. Okay, now what basically happens in this. First of all, going through this important paragraph, it says that like we know that seawater is salty due to the presence of dissolved salts in it, right? But however, the salt obtained through the process of evaporation, it is impure and it has some small crystals in it, which makes it difficult to see their shape. So large pure crystals can be obtained from a solution using the process of crystallization, which is physical change. What I mean to say that we know salt water, like seawater, it is salty because salt is dissolved in it, right? So normally the process of obtaining salt from the seawater is simply by evaporating that water. Like what people would do, like say that this is seawater, for example, and this is the land. So people would be collecting the seawater into these structures. In this, they will be collecting the seawater and they will let it to dry in the sunlight. So water will dry and you will be left with salt. Okay. So basically, with the help of evaporation, we are getting the salt here. But the salt that is obtained through the process of evaporation, it is impure. It is impure because it has so many other impurities in it now. Can we directly eat that salt? Yes, Rosan? Can we just go to the beach and we just take out some salt water? We take the seawater, evaporate it in the sunlight, and the salt will be left. But is that salt pure? Obviously, no. It is not for fit for consumption. So it is impure. So thereby, it has to be crystallized. It has to be crystallized in order to obtain pure crystals of salt from it. Okay. So crystallization would be the process of obtaining crystals of pure substance from a impure solution. The basic principle of the method of crystallization is that, first of all, do you understand what is a concentrated solution?
What's it?
What is a concentrated solution? Are you getting this term? Like, what does it mean?
Can you repeat it again?
Concentrated solution. Here, this term concentrated solution is repeatedly being used. Have you studied about?
No.
Okay, okay. Let me first of all clarify this. Only then it will be easier for you to understand. Okay. See, a concentrated solution will be such a solution. Let us say, for example, you have taken a glass of water. So how many tablespoon of salt you can add? Let's say you can add 1 tablespoon of salt in this. Okay. One, let's say two, let's say three, let's say four. But beyond four, let's say no more salt dissolves in it. Beyond 4 tablespoon, no more salt is able to dissolve in it. If I were to add the fifth tablespoon of salt in this, that will not dissolve in it, but it will deposit at the bottom. Getting it what I'm trying to say?
Yes.
So while I had dissolved 4 tablespoons of salt in it, it was the maximum amount of salt that could have been dissolved in this water. So that water is called as concentrated water, because no more given salt. It could be any other thing also, like sugar also. So no more salt or sugar can be dissolved in that water. So that will be then called as a concentrated solution. Getting it? Like it
Yes.
contains a large amount of dissolved substance in it. It contains a large amount of given substance in it. Okay. Beyond that, no more substance will be dissolved in it. Okay, now. So when we
Yes.
keep on adding so much of given substance into a liquid, it after some time it will become concentrated, meaning that no more of that substance can be added into it anymore. So similarly, let's say that you have taken a very concentrated solution of salt water or sea water. Say that you have taken a very concentrated solution of salt water. Let us say now, okay, that this is the sample of seawater in this glass, and it contains lots of salt in it, so much that it is now concentrated. No more salt can be dissolved in it. Okay, Rizan. But why the process of evaporation? It is not good. Like we can't consume the salt simply by evaporating the water, because impurities will also be present in it now. Right, Rizan?
Yes.
So what I will be doing now, first of all, I will be heating this. Okay, now I will be heating this, and then I will be cooling it down. First thing, I will be heating it, and then I will allow it to cool down slowly. I will allow it to cool down slowly. In that manner, I will be able to obtain pure crystals of salt from this impure solution. Got the principle of crystallization or not?
Yes.
Okay, now we have one particular example where we'll be learning about crystallization of copper sulfate solution. Okay, we'll be learning about that in detail. Okay, so let us understand this one. Also, an important thing to be considered that this crystallization, it's a physical change. Why we are considering this as a physical change? Because it's not like a new substances form. Huh? Like earlier also, when this was an impure solution, it contained salt in it. No? Salt. After crystallization also, I will be obtaining the same thing, that is salt from it, but it will be pure in nature. There will not be any impurity. By property, we are not getting a new substance. When we look at the property, earlier also it was salt, now also it is salt. Getting it, Razan?
Yes.
So only you are getting the crystals of the given substance, not a new substance. So that's why it is a physical change, and this crystallization will be mainly used for purification of some of the substances. So here it's a process by which a pure soluble substance separates out in the form of crystals from its hot and saturated solution on cooling. So let us say that we are doing it with the copper sulfate solution. Right now, let's say that you have some impure copper sulfate solution. Now you want to obtain crystals of copper sulfate from it. Just have a look at the crystal of copper sulfate. By the way, this is crystal of copper sulfate. This one. Getting it, Razan?
Yes.
So what we are going to do, first of all, we are hmm, first of all we are going to take some copper sulfate. Okay, we have taken some copper sulfate in this, and let me just write down the steps. Right now we are learning about, our objective is obtaining crystals of copper sulfate, obtaining crystals of copper sulfates from
Are
a,
these
yes,
the steps?
yeah, these are the steps which are going to write down. Okay, now. So we are obtaining crystals of copper sulfate from an impure solution. Okay,
Yes.
that is what we are doing. So what we are going to do here, like we are going to take some copper sulfate first of all. Then we are going to add some water into the copper sulfate. Okay, like you can take some powder of copper sulfate. Copper sulfate. Remember you saw that video where we had copper sulfate in the form of powder. So we are going to take some. Step number one will be take some copper sulfate and add water to it. And we're going to add water to that. Okay. Then later on, we are going to take some acid in this also. We will be adding some drops of acid into this also. So in step number two, add some drops of acid. Let's say, by the way, we can take any acid. Let's say here we are taking sulfuric acid. Okay. So we had added some sulfuric acid in it. Got this? We had taken some copper sulfate, added water, and also added some acid to this. Now we are going to heat the given solution for some time. Okay. We are going to heat the given solution for some time. So step number three involves heating the given solution. Okay. Also note down here that this copper sulfate is not being directly heated, but it has been placed over the boiling water here. Note down how it is being heated. It is not directly being put over the burner. This copper sulfate, which also contains some acid in this, like sulfuric acid is present in it, it is being put over this boiling water. Okay. Got this so far, Razan, or not? Please let me know.
Yes.
So now we are going to, once we have heated it, now once it has been heated, so we'll be heating it for some time. Okay. Then we are going to filter it down. Okay, now like we are going to filter it down. So filter the solution. Like here in this image, it is not shown, but we are going to filter it with some filter paper or some filtration thing can be used to filter it down. Then step number 5 will involve to allow it to cool down. Okay, na? So allow it to cool at room temperature. At room temperature. It's not like we are going to put it in a refrigerator. We are going to simply allow it to cool at the room temperature. Then after some time, we will observe that crystals will start to appear. Like here, you can see that crystals have started to form in this. Getting it? Just
Yes.
look at this. This is the actual process of the formation of copper sulfate crystals, as you can see here. Okay, now understood the whole thing?
Yes.
If there's any confusion in it, please let me know.
No, sir.
So that is the thing. So here we have separated out crystals of copper sulfate from a very hot and concentrated, hot and saturated solution. We allowed that solution to cool down for some time, and then we obtained crystals from it. So that was the thing. And now in nature, you can see some of the crystals. Okay, now
Yes.
like this one is stalagmites. So stalagmites are also, you can see like these are the some of the crystals found in the nature. Getting it? So stalagmites are crystals formed in the nature, and they will be taking lots of time. These crystals are formed in a very long period of time. Okay, so that is one thing. Furthermore, we have some other examples of crystallization also, like when when there will be a volcanic eruption. So when magma will come out, and magma will also cool down, and over the course of so many years, that will also form into crystals. Getting it? What I'm trying to say? Okay, that is one thing. We have some other examples also, like in the case of this one, we have seen like this one is, by the way, stalagmites. These are stalagmites and usually will be formed under the caves. Also, diamond and rubies, they are also examples of crystals. Getting it? So they are also formed by the process of crystallization only. Okay. Now we have this interesting question that can physical and chemical change both occur at the same time? What do you think of this, Razan? Can both the changes occur at the same time?
No.
No. Think of the burning of a candle. When a candle burns, you see the wax is melting,
Yes.
right? And
Yes.
the wax is burning as well. It's burning, and the thread of the candle that is also burning. So both the changes are happening at the same time now. So the melting of the the melting of the wax, it's a physical change because after melting, not a new substance is formed. New substance is not formed here. But when the wax burns now, when the wax converts into wax vapor and it burns, there it's a chemical change. Okay. And the thread, we can count that also, like the thread, that is also a chemical change here. So the burning of a candle is a combination of both physical and chemical change. That is the example of burning of candle, where we get to see both the physical and chemical changes. So talking about the burning of the candle. So here we get to see that the chemical change that is happening here, the wax that is melting, I mean to say the wax will be evaporating due to the heat now.
Yes.
So wax is evaporating, and it will be reacting with the oxygen in the air, and hence forms new substances like carbon dioxide and water, and forms some soot also, and releases some heat and light also. What I mean to say that in the case of the burning, this is what is happening here. Talking about the chemical change. In this, what happens? The wax is burning and converts into wax vapor. Converts into wax vapor. Basically, the gas state of the wax is called as wax vapor. Furthermore, the wax vapor will be reacting with the oxygen. In the process of doing so, it will release carbon dioxide gas. It releases carbon dioxide gas. Along with that, it also releases some new substances like soot, plus it also gives out water vapor also. So here what we are seeing, that the wax is going through a chemical reaction where new substances are formed. So this is the chemical change taking place when a candle is burning. Getting it now?
Yes.
Okay. Talking about soot is basically the unburnt particles. Soot is the unburnt particle which does not burn completely. Like if you were to place a glass sheet above the candle now, like if I were to place a sheet of glass above the candle, so a dark patch will form on this. A dark colored patch will form on that glass sheet. Have you ever observed that? A
No.
black spot forms. Like we can do it with a paper also, like just hold it slightly above the candle flame, and a black dark spot will appear at the center of the paper or at the center of the
Yes.
glass sheet. So that is basically, that contains soot. Okay. And where is it coming from? It is coming from the wax. When wax converts, like it contains wax converts into the wax vapor. And due to the heat here, due to the too much of heat, the wax vapor is reacting with oxygen to give out carbon dioxide gas. Carbon dioxide gas is given off, water vapor is also given off, and soot is also given off. So that is the chemical change happening here. But when we look at the melting of the wax is considered as the physical change. So when a candle burns, so the wax near the wick, like this is called as the wick now, the thread is called as wick, right? So the wax near the wick, it melts, and upon melting, it converts from the solid to the liquid state. So which is a physical change because the composition of the substance remains the same, right, Luzan?
Yes.
So melting of the candle here, what happens that wax from the solid state converts into the melted wax,
Sir,
which is in liquid state, right? Yes, Razan.
in that equation, wax vapor plus oxygen to carbon dioxide plus what is the other one?
Soot, SOOT. Okay. Soot was the dark patch that forms over the glass sheet if I were to hold it above the candle flame. So this is the classic example where both of the changes are taking place. Okay. Done.
Yes.
So that is the thing. Okay. Now we have this question that give a reason why freezing of water is a reversible change while burning of a candle is a irreversible change. Meaning that you can reverse the freezing of water, but you can't reverse the burning of a candle.
Because freezing of water is reversible change because uh, when you remove it from and keep it in heat, it melts. So if you take it turns into liquid. So when you take it and put back it into the freezer or fridge, it turns cold. So it's a
Hmm.
reversible.
Okay. And about the burning of candle, what you said?
And the wax of the when the wax is burning, it changes into wax vapor.
Which is lost into the air, so that we can't get back. Okay, no, the wax that has evaporated in the wax that is converted into the wax vapor, it is lost into the air, so we can't get it back. Getting it now? So that's an irreversible change. Okay. So there was one more thing to be discussed is the difference between physical and chemical changes. So there are some basic differences, like in the case of physical change, the the chemical composition does not changes, only the physical property like the state will change, its temperature, its color, its shape and size will change, right? But in a chemical change, the chemical composition of the matter changes, like a new substance is formed here, okay, now with completely different property. While physical changes are reversible with some, it can be reversed, okay, now while chemical changes are irreversible in nature. In physical changes, new products are not formed, but in chemical changes, always a new product will be formed. While some changes occur when heating or cooling is done, while here in the case of chemical change, changes always involves absorption or release of energy, right? Furthermore, there was one more thing, but that we'll be learning in higher class about the chemical bond. That's a different thing. Okay, now it's time to do the questions. So start from here. Read the question and answer it.
Substance retains identity. What are we supposed to do in this?
State which of the following pertains to chemical changes. That's the question. Like, what are the things that you will get to see in a chemical change?
I can't understand.
It's a question. Like, question is that which of these options, which of these properties are related to the chemical change? Which one of them will be observed in case of a chemical change? There can be multiple answers to this.
G.
How can it be option number G? No. The composition and properties of the original substances are not altered. Altered here means changed. The word altered means changed. Okay.
Yeah, not G, not G.
Hmm.
What's the meaning of F? What does it say?
The change is temporary. Which one you are asking?
Yeah, that only. What does
The,
it mean temporary?
okay, temporary. Temporary means that after some time it can be reversed. Okay, now like change of the water into solid or liquid or the gaseous state, it is temporary, meaning that it can be reversed back into the original state.
E.
Option number A, you are saying.
E.
E. Ha. So it produces one or more new substance by change in its composition. Very good. This is correct. Okay. Okay. So this is the most appropriate answer to this. Okay. Although option number B, the change is permanent. That is also correct now. The change is
Yes.
permanent in most of the chemical changes. That is the thing. Okay. Let us do these questions as well. Look at the first question. Which of the following is a physical change here? Go through the option and then answer it accordingly.
What is the meaning of combustion of a magnesium ribbon?
Combustion means burning of something in presence of oxygen. Whenever something burns in presence of oxygen, so it's called as combustion.
Melting of wax.
That is correct. Melting of wax is a physical change. Very good.
Only one will be there in each.
Yeah, there will be only one correct option in these.
Cooking of vegetables.
Correct. Next.
Any or all of the above.
Exactly. Good.
Its state is changed from liquid to semi-solid.
Which of the following is R2? See, there can be multiple options correct in this one. Look at the following here. No, choose the correct option from the below here. A, B, C, and D.
D.
Option number D, you are saying 1 to 4. All of them are correct.
Yes.
Okay. Does the color changes? Uh, when milk is converted into curd, its color does not changes now.
No.
Okay. Its color basically remains same. That is white. So thereby, which option is correct now?
1, 3, and 4.
1, 3, and 4. That is option number C. Very good. Okay. Now go on to question number 5. A man painted his main gate made up of iron tube.
Prevent it from rusting.
Prevent it from rusting. Good. That is option number 1 only is the appropriate answer. Question number 6. Now there was this interesting case of iron pillar. Now, okay, let's learn about the iron pillar. Okay, let's learn about the iron pillar also. So talking about the iron pillar, so the iron pillar that is near the Qutub Minar in Delhi, it is very famous, and there is a reason why it is famous. Like this was built almost 2000 years ago. About 2019 years ago it was built. Getting it? Meaning that it
Yes.
was built in the year 5 CE or 5 AD. Right now it's 2024, but this was built in the year 5, in the 5th century it was built. Getting it?
Yes.
Not in the 5 area, I say. Like it is in the 5th century, I mean to say, sorry. Not in the 5th area actually. But in the 5th century, I mean to say actually. Okay. In the 5th century it was built. Getting it? The exact date is not known, but it was built in the 5th century. Getting it? Like somewhere around 420, 430 or 450 AD it was built. So almost about like 1600 years ago it was built. What is special about this iron pillar is now that it has not rusted over such a long time. It hasn't rusted. That's why this iron pillar is very famous. Getting it?
Yes.
Why? Because the composition present in it is so special that makes it rust free. Getting it now?
Yes.
So this was built by the Chandragupta Vikramaditya. There was a person, there was a king by the name of Chandragupta Vikramaditya. So he built this iron pillar that is near the Qutub Minar. Okay, and this is about 7.2 meter in 7.2 meter tall. Okay, or it has been famous. It is very famous because of its rust-free property, and it is very heavy, like weighs about 6,000 kilogram or something like that, around 6,000 kilogram. But the important point, it has not rusted over such a long period of time. So the correct answer is that.
It has not rusted after such a long period.
Hmm. Question is, which of these fact is responsible for its long stability? Iron pillar the near Qutub Minar in Delhi is famous for the falling facts. So which one of them is responsible for its long stability?
Mm.
Uh, what could have been the reason for its stability? Why
It
is
has,
it still standing? Uh-huh.
it has rusted.
It has not rusted after such a long period of time. Very good. Okay, na? Otherwise, the weight and the height and how long ago it was made, that doesn't really affect. That doesn't really matter if it would have rusted. The important thing is that it does not have rusted. That's why it has been standing for the past 1600 years. Okay. Now, question number 7. Answer this one.
Mhm. Zinc.
Option number D.
Zinc. D.
No.
Yes.
Galvanization we have learned with this now.
Yes.
We have learned about galvanization. Like we
Yes.
have to prevent the iron from rusting by applying a coating of zinc above it. Yes, Razan. So galvanization is a process used to prevent the rusting of iron. Okay. Okay. Answer question number 8.
Paheli.
Bailey's mother made a concentrated sugar syrup by dissolving sugar in hot water. Now, on cooling, crystals of sugar got separated. So, what does it indicate?
Mm.
In fact,
Physical change that can be reversed.
exactly. Okay, no, it can be reversed. By adding some water in it again, it can be reversed. Okay. Okay. Question number 9. Answer this one. Which of the following statement is incorrect for a chemical reaction? Is Ruzan, you there in the class?